Searching for a particular image of a well-photographed object using conventional tools often results in a large number of images that are not ordered in an intuitive way. Finding the exact picture we want can mean browsing through page after page of thumbnails. How can we organize such large photo collections in a more intuitive way? In this project, we present a novel system for registering large sets of photos and exploring them in a 3D browser. Our system discovers the relative positions of the cameras used to take each photograph, situates the photos in 3D space, and provides intuitive controls for exploring the scene and finding interesting photographs. Our system takes a collection of photos of the same scene as input. We first find key points in each of the input images, then match key points between each pair of images. Next, we run an iterative bundle adjustment procedure to estimate the parameters of each camera and the positions of the observed 3D points. Once the photos have been registered, they can be browsed using our photo exploration interface. Our system provides standard controls for moving around a 3D scene. In addition, when the user selects a photograph, the virtual camera is smoothly brought into alignment with that photo. Information about the photograph appears in the information pane on the left. Our system provides several intuitive ways to select new photos. One is to select an object. The user can highlight a region of the current photo, and the system automatically finds a good photo of the selection, and smoothly moves the virtual camera to the new photo. During transitions, we use a simple plane-based morph to provide context as the camera moves. A thumbnail pane along the bottom of the screen shows other photos of the selected object. When the user moves the mouse over a thumbnail, that photo is displayed in the main view, projected onto a planar approximation to the selected object. Here, the user selects a thumbnail to see a different view of the statue. We also provide tools for viewing the scene at different scales. The user can step back from the scene with the Zoom Out tool. This finds photos that display a larger area of the scene. The Show Me Similar Images tool finds images of the scene with scale and orientation similar to that of the current photo. The Zoom In button finds details, showing the user what parts of the scene can be viewed at a higher resolution. Here the user selects a photo of the bas-relief in the upper left, and the browser zooms into the more detailed photo. Our second example uses a set of photos taken by one person over the course of 2 days. We registered the photographs and reconstructed line segments as well as points. We can align the reconstructed model with the satellite image to situate it in a georeferenced coordinate system. We render the scene using the reconstructed line segments. We also project blurred, partially transparent versions of the photos onto the scene to convey more information with a non-photorealistic look. An overhead map is displayed in the upper right. The user can select a photo using the map. Here the user selects a building to see a photograph of it. For this dataset, we can also move left and right along a row of building facades. We provide geometric controls for this type of interaction. For each photograph, we pre-compute a left and right neighbor based on the projected motion of the points observed by the images. We also pre-compute a step-back image, so the user can quickly view more of the scene. In this example, we explore photos of the Notre Dame Cathedral in Paris, downloaded from the web. The user can select regions in the point cloud to find images of an object. Our system also allows users to annotate photos. These annotations are automatically transferred to new images. Here the user labels several regions of the current photo. As each region is labeled, we transfer the annotation to the other photos. The transferred annotations are highlighted in the thumbnail pane. So as not to cover the photos, we'll hide the panes and use a hotkey to step to the next photo in the sequence. As we move to each photograph, the annotations appear. Our system uses simple heuristics to determine if an annotated region is occluded, as in this example where one region is hidden. We can also transfer annotations from other sources, such as annotated images on Flickr. In this scene, we've also added several other annotations by hand. Our annotation transfer algorithm is sensitive to scale. If we look at photographs taken at different scales, we see different annotations. Next, we explore a set of photos of Half Dome in Yosemite National Park, gathered from the web. If the user finds a viewpoint they like, our system makes it easy to find images taken from a similar viewpoint. By selecting the Lock the Camera option, we can generate a slideshow where an object remains fixed in the view. Now we unlock the camera. We can also register historical imagery, such as this photograph of Half Dome taken by Ansel Adams in 1960. Here's our estimate of where Ansel was standing when he took this photograph. Here we compare the photograph to a synthetic rendering from the same location. The white border has been manually added for clarity. Our final example is a scene created from about 80 photos of a walk along the Great Wall of China. We organized about 20 of the photos, seen here, into a slideshow. We have experimented with an alternative morphing technique that creates a mesh from the 3D point cloud, which is used as an imposter for the true scene geometry. This method often works well for nearby viewpoints, but creates artifacts in cases where the matching fails. We hope you have enjoyed our 3D photo tours.